Hello, I'm Brandon DePaulis. Welcome to my presentation on the WISE spacecraft, a helpful instrument in our creative fire. The WISE spacecraft shares a distinctive similarity to R2-D2 from Star Wars. An overview of WISE: the WISE telescope was launched in December of 2009, specifically December 14th. Roughly, it is the same height and weight as a larger polar bear, but the width is where contrasts are evident. It is composed of two main sections: instrument section and spacecraft section. The instrument was designed and tested in the Space Dynamics Lab in Logan, Utah. It features a 16-inch telescope tube and 4 infrared detectors. And as I said earlier, it has an uncanny resemblance to R2-D2 from Star Wars. I mean, just look at that. It also contains a cryostat that cools all of the infrared detectors, allowing them to do their job and find asteroids, other planets, anything, all of the above. The WISE spacecraft, unfortunately, was put into hibernation mode in 2011. However, in 2013, it was revived and renamed. The new name for this spacecraft was the Near-Earth Objective Wide Field Infrared Survey Explorer, or for short, NEO-WISE. After being revived, it then discovered thousands and thousands of smaller planets and star clusters. It discovered the first Wide Dwarf class star, which is also known as the coldest star type. And here, a picture it captured. WISE captured this picture of a unique nebula. As you can see, it looks like a heart and a lung, the red part. And then, as you can see, countless and countless stars just lost in all of the vast infinity that is space. How does the WISE work? Well, part one of how WISE works, because it's a very long and complicated process. The WISE satellites 40-inch diameter images broad areas of the sky. It contains 12 mirrors coated in gold to improve reflective capability. These mirrors are actually made of aluminum, but the gold actually serves as the main coat due to the fact that gold in general reflects reflectivity. They cancel out the direction of the spacecraft by moving at the exact rate that allows for freeze frames to be taken every 11 seconds. The mirrors then form a focused image of the sky onto the detector arrays. They then pass through diaphoric filters that transmit and reflect waves, depending on which they are. This allows WISE to capture images of the sky at 14 different types of at 4 different types of wavelengths. These pictures are all taken simultaneously and are all produced together. And as a layout, as previously described, you can see the telescope barrel, the secondary mirror support, the bath, as seen right here, the primary mirror, and then if you go down here is the scan mirror reflection, and the light exit. There's also multiple light exits, as you can see, where the light is seen reflecting from here, bouncing off, and then going through here, and as it moves out. Then, part 2 of how it moves, the image quality resolution is so great that it can distinguish differences at extremely small amounts. There are several small amounts that it can distinguish. There are 4 micron bands: 3.4, 4.6, 12, and 22. In the first 3 bands, it can distinguish features that have a difference as small as 1/600th, meaning that 2 frames could be almost exactly the same except for one little tiny speck, and it could just immediately find that difference. In the first 3 bands, in the fourth band, it can differentiate features that differ as small as 1/300th. Not quite as small as 1/600th, but still insanely small. In other words, this means it can distinguish features about 5 times smaller than the Infrared Astronomical Satellite, or IAS, could, and hundreds of times smaller than NASA's Cosmic Background Explorer. This is another image of WISE, showing just another cluster of stars that in the vast infinity of space. And here are some interesting facts about the WISE spacecraft. It is one of 6 infrared-based telescopes that are space-based. It has discovered, to this day, over 33,000 new asteroids. It helped accurately calculate the diameter of over 129,000 asteroids. WISE was instrumental in helping NASA achieve a congressional goal of discovering 90% of neo-asteroids. And it's estimated the WISE mission cost was between $300 and $350 million in US currency. And here I took on liberty myself to try to recreate a diagram of the anatomy of the spacecraft. As you can see, the support, more clearly labeled and pointed to is the metal beams on the top. Then the telescope barrel is where all the light is shown and is allowed to bounce off. And then the baffle, which helps a lot, and then the second mirror. Then you go down here, you have, of course, your light exits, your scan mirror mechanism, and your scan mirror. Interesting, oh wait, no, my apologies. And then, you see another version of how, in general, an infrared telescope would work. So, you have the target, you have your atmosphere, the sun comes into here, and the infrared telescope goes from here and then here, as you can see. As the WISE spacecraft is one of 6 infrared-based telescopes, was launched in 2009. It is relatively new and is more is known than was then back in 2009. What about the remaining 5? The list of infrared telescopes includes the Infrared Astronomical Satellite, which was launched in 1983. The Spitzer Space Telescope, which was launched in 2003, and was just deactivated during the lockdown, during our COVID lockdown in 2020. It also contains the Herschel Space Observatory, which is active mainly from 2009 to 2013. The Nancy Grace Roman Space Telescope, and the James Webb Telescope, which my cousin actually worked on design. Interestingly enough, 2 of the spacecraft had overlapping missions. The Herschel Space Observatory and WISE spacecraft were both launched in 2009 and remained active until 2003, when the Herschel was shut down. All of these spacecrafts are unique, but all have helped contribute attributes that move us closer to understanding the mystery that is our universe. And here, just for comparative reasons, this is an image taken from the Herschel Observatory, which could be called the predecessor of the WISE, even though it was launched at the same time. So this, as you can see, is nowhere near as clear as images from the WISE. If you look, images from the WISE, if you look over here, nowhere near as clear. This just shows how advanced WISE was for its time being. WISE really was a gem, a hidden gem. And here is another picture of WISE capturing the aftermath of a supernova. As you can see, once again, there is just all the elements of the cosmos just here captured for our eyes that we would not be able to see had we not had great inventions such as the spacecraft. And one more, one of the best constellations, not in the greatest quality, of course, because it's so far away, but this is supposed to be Orion being captured from the WISE telescope, and it is just purely breathtaking considering that everything that we have created in terms of seeing things that are thousands and hundreds and millions of miles apart from us. Thank you for listening.